So guys, going forward, let us try to understand the destination IP address in real sense. Let us suppose the L3 router A wants to send data with destination IP address X, where X could be 192.168.1.1 or 193.168.1.1 or 10.168.1.1, or it could be 11.168.1.1 or 12.168.1.1. Then B will consume the data. That is, if router A sends the data with destination IP address is equal to IP address of any local interface of router B, then when router B will receive the data, it will going to consume the data. Consume the data means the layer 3 of the TCP IP stack will conclude that the data is destined for router B, and it will hand over the rest of the packet to the transport layer or application layer running above the network layer in the TCP IP stack. So you can see that the router A can send the data to the router B by specifying the destination IP address as IP address of any local interface of router B. So this is the criteria of receiving the data and consuming the data by a machine. That is, destination IP address must be equal to the IP address of any local interface of a receiving machine. But what if A sends the data with destination IP address X, where X is equal to, for example, 10.168.1.3, right? So in this scenario, the L3 router B will going to receive the data, but it will not consume the data. Rather, the router B will use L2 routing to further send the data to the machine C, right? And when the machine C receives the data, it will check that the destination IP address in the IP header is equal to the IP address of its local interface. So this condition becomes true and the machine C will going to consume the data, right? So router B, when receives the data such that the destination IP address is not equal to any IP address of local interface of the router B, but the destination IP address falls in one of the local subnet of L3 router B, then router B will forward the data further in its local subnet to which the data is destined. So these two are basic principles that clarifies or which states the criteria of receiving and consuming the data or further propagating the data to the machine present in the local subnet attached to the L3 router. So if condition 1 is satisfied, the data will be consumed, and if this condition is specified, then L3 router further forwards the data using L2 routing in its local subnet. So L3 routers talk with each other via L3 routing only. So L3 routers talk to each other using L3 routing only, whereas L3 routers talk with machines present in its local subnet using L2 routing. So in our example, if the router A sends the data with destination IP address equal to 10.168.1.3, then the data will reach gateway router B using L3 routing, because the destination machine which is supposed to receive the data, that is the machine C, is present in one of the local subnet of router B. So you can see that the journey of the packet is divided into phases here. The first phase is the L3 routing. Using L3 routing, the packet eventually reach the destination gateway router. And in the second phase, the destination gateway router uses L2 routing to eventually deliver the packet to the destination machine. Right? Also note the point here that each interface of L3 router is a subnet. So you can see that in this example, this interface represents a subnet 192.168.1.0/24, and this interface represents a subnet 193.168.1.0/24, and so on.